when we are converting, anytime you see that word converting, at this point you should be kind of training yourself to think that we are doing dimensional analysis, which is going to be that T-chart process. So if I'm looking at example A right here, it says find the mass of 0.0450 moles of chromium. So the question is asking us to find the mass, which means what unit will we end in? When we're done converting in this question, what unit do we measure mass in? Grams. Okay, good. So put grams there, and that's already earned you a identified that we're looking for mass. Good. And our given information, what we're starting with, is this. So that's still my given. So I'm going to start with my given at the beginning of the question of 0.0450 moles of chromium. And if you don't know the symbol for chromium, do not make one up. You need to look at your periodic table. Chromium is this one. It's spelled out for you. So we're going to say Cr, moles of Cr. We're going to disco down our units. So just like we did previously when we had this process, whatever unit I have here, I'm going to put that same unit down here. So I'm going to put moles of chromium at the bottom. And then the conversion factor between moles and grams, so I can go directly to grams of chromium because I have that conversion factor of molar mass to get me between grams and moles of anything that's on our periodic table. So the definition of molar mass tells us that 1 mole of chromium is equivalent to the number of grams on our periodic table for chromium, so 51.996. So I'm going to put that in here. 51.996. And then just like every other time that we solve these problems, remember we're multiplying everything on top and then you divide everything on bottom. So when you plug this into your calculator, you're typing in 0.0450 times 51.996. And then you'd technically divide by 1, but again, that doesn't change your answer, so you really don't need to type it in. And then I get this number right here. So even though we are not rounding molar mass, we're using the exact molar mass within our boxes, we still are going to round our final answer. So if you're looking out here, our final answer needs to have the same number of significant figures as our given. This given information has 1, 2, 3 significant figures. So that means our final answer would also need to have 3 significant figures. So if I'm looking at this, 2.339 would round to 2.34 to have 3 significant figures. And then before we pack up, I want to do one last question and then we are done. The example says, if you weigh out 90.5 grams of aluminum, how many moles do you have? So in this question, what unit are we looking for? What are we trying to end in? Moles. And my starting information is still going to be my given. So 90.5 grams of aluminum. Thank you. If I have grams of aluminum up here, I'm going to bring grams of aluminum down here. And then my question is, can you go directly from grams to moles? Is that something we're able to do? Yes, our conversion factor is still molar mass. So you can always go from grams to moles. I want to be specific that it's always going to be the same substance for grams to moles. So grams of aluminum to moles of aluminum. The conversion factor, because molar mass is always 1 mole, is the number of grams of aluminum on our periodic table. So with this, I can find aluminum, and the molar mass is 26.982. So I would write that in here. And then on this question, because this is on top and this is on bottom, we need to remember that we are actually dividing here. So it'd be 90.5 technically times 1, and then divided by 26.982. So take a second and type that into your calculator. 90.5 divided by 26.982. And then once you hit enter, again we have 3 significant figures, 1, 2, 3. So our answer has to have 3 significant figures. So 3.35 is what I would write down for our final answer.